This is unit 4. We have finished unit 2. Okay. So next I am going to discuss unit 4 and 5 because unit 1 and unit 3 are purely theory. Let us discuss those at the end. Unit 2, unit 4 and unit 5 involves a little bit of problems and those are little bit mathematical. So let us discuss unit 1, unit 2, 4, 5 once and at last unit 1, 3. Unit 4 consists of probability. There is a chance that you will get a problem from unit 4, fitting of binomial and Poisson distribution. So it involves the concepts like probability and probability distributions. Unit 4 consists of probability and probability distributions. So the first half is nothing but what is probability, and let us define certain terms in this. Probability is nothing but whenever we have uncertainty in any phenomena. So what do you mean by uncertainty? So simple example I'll take. If I calculate 4 into 5, what is 4 into 5? If you consider this as an experiment, finding the value of 4 into 5 as an experiment, it's always 20. It doesn't change, the values are not going to change from person to person or time to time or place to place. So whenever you conduct an experiment, if the results, this is called an experiment, this is called result. Whenever the results of an experiment are fixed and certain, we call the experiment as the phenomena as there is a certainty in the experiment. So these are where there is no confusion in conducting the experiment or obtaining the results. So if you take a simple example like tossing a coin, if you consider coin tossing experiment, so what are the possible outcomes? You know there, head, tail are the possible outcomes. So whenever you have two outcomes with respect to whenever you have coin tossing experiment, these are the results observed. So if I toss the coin, so if I am the person who is tossing the coin, there is a chance that we cannot get head or tail if I toss for the first time. So let us say that after tossing the first time I had appeared. If I toss for the second time, what is the chance of what are the outcomes you may expect? Again you may get head, maybe tail. Means whenever an experiment is conducted with repeated trials, you are repeating for a number of trials and results in that experiment are not unique. Okay, not unique means they cannot be, there is no certainty in the outcomes of the experiment. Means we know that either a head appears or a tail. You cannot say that in the first trial you will get only head, in the second trial only I am going to tail. So whenever we have uncertainty in the results of an experiment, such an experiment is called random experiment. Okay, an experiment which is repeated under the same or identical conditions, but the results of the experiment are not unique and maybe from the available possible outcomes. If you observe the uncertainty in the pattern of the outcomes, we call such an experiment as random experiment. So the outcomes, what are the, if you take the same example, what are the outcomes here? Head, tail are the outcomes. The outcomes of a random experiments are called events. Okay, the total outcomes, the total events are called exhaustive events. So what are the exhaustive events in tossing a coin? 2. If you consider throwing a die, so what are the possible outcomes there? All the 6 faces of the die are nothing but the outcomes there. What are the exhaustive events there? 6 are the exhaustive events. So we have described what is an experiment, what is an random experiment, what are events and what are exhaustive events. Now whenever we have uncertainty in the phenomena, then always a question arises that I said that a head appears or a tail. Then my question is that what is the chance of getting head, or what is the chance of getting tail? Whenever we have no certainty in the phenomena, then we use the word like chance. What is the chance of getting head? What is the chance of getting tail? So this chance is called the probability here. Or how probably the head appears, means what is the chance whenever we have a uncertainty in the phenomena, to guess the outcomes of the experiment we use the word called chance. What is the chance of getting 6 when I throw a die? Then this chance phenomena is called the probability. The chance is same as nothing but probability. It means what is the probability of getting tail? What is the probability of getting head? So this is about the probability. Generally, after defining exhaustive events and probability, next we are going to define mutually exclusive. There are certain definitions you may get in the examination. Mutually exclusive events I am going to define. What is mutual? So if I am going to take the same experiment, that is tossing a coin, what are the possible outcomes? I may get head or tail. Now, when do you say the events as mutually exclusive? If I toss a coin for once, okay, so let us say that tail appeared. What does it mean? Tossing a coin in the first trial, the results is nothing but tail. So in the first trial, if tail appeared, means there is no chance of appearing, there is no chance of appearing head. Means if the happening of one precludes means prevents the happening of the other event, we call the events as mutually exclusive events. So the same one, if I consider the problem of throwing a die, I think these are the possible outcomes of throwing a die. So let us say that when I throw a die for the first time, a number 5 appeared. What does it mean? The remaining 5 numbers cannot appear in the first trial. It means that if the happening of one precludes the other, means head appeared, means there is no chance of appearing tail in the trial. Means if the happening of one precludes the happening of the other, we call the events as mutually exclusive events. The next one is nothing but equally likely events. What if name itself tells that equally likely events. So let us say that the same experiment, head comma tail with the possible outcomes. In the first trial, the outcome of the experiment is head. Okay. So what is the second? What is the chance of outcome? What are the possible outcomes for the second trial again? Either a head again, maybe tail. Means I cannot say that head appeared in the first trial, so there is no chance that I'll get head in the second trial. Means there is no priority to any events. All events are equally likely events. Any outcome can appear for any number of times. If all the events are given, equal number of equal chance to appear, we call the events as equally likely events. So these are the certain definitions here. Then how do you define the probability? Probability we define as probability of occurring an event. Events we indicate with capital letters. P of E indicates probability of happening an event, which is defined as favorable number of events by total number of events. Okay, we have certain numerical problems also. So this is the definition we use. Probability of an event happening an event is denoted with P of E and is defined as favorable number of events by total number of events. Generally, probability lies between 0 to 1. So either you cannot get a value beyond 0 or beyond 1. So whenever P of E is equal to 0, we call the event as impossible event. Means there is no chance of happening such event. So the best example, while tossing a coin, what is the probability of getting 7? I think there is no chance of getting 7 there. So P of E is there 0. So whenever P of E is equal to 1, we call that as certain events. So with this we have described what is probability and what are the different terms involved in that and definition of probability and the formula for probability. So here coming to the numerical problems, you can classify the problems into three categories. Okay, what are the three categories means? One, without using the problems without using addition or multiplication or Bayes theorem. So in the first section of problems you are going to do without using any theorem. In the second one you will use either addition theorem or multiplication theorem or Bayes theorem. In the third one you are going to do fitting of binomial distribution and Poisson distribution. So generally you will get numerical problems from probabilities. They can be classified as problems without using the theorems, problems with using these theorems, and these are completely different one, fitting of binomial and Poisson distribution. Among these three problems, if at all you won't get, if there is no question from these two parts, there is a high chance that you will get a problem on fitting of Poisson and binomial and normal distribution. So either you can concentrate problems from this section or this section, so that you can answer from fourth section you can answer a long answer. You will be able to answer a question from unit 4. Got it? Addition, multiplication without these theorems, with theorems, and fitting of binomial, Poisson and normal distribution. So let us do a simple problem from your book, only page number 238. If you look into that, a bag contains 10 white balls. A bag contains 10 white balls, 6 black balls, and 4 black balls. A bag contains different combinations like 10 white and 6 black balls, and 4 balls are successively drawn out and not replaced. How many balls are drawn? 4 are drawn and not replaced, and they are not replaced back into the bag. Now what is the probability? The question is, what is the probability that they are of alternatively different colors. They are of alternatively different colors. So again I repeat the question. Now it is given that a bag contains 2 different types of balls, 10 white and 6 black balls, and 4 are drawn from it, and the question is, what is the probability that they are of alternatively different colors? How can you classify the problem is from first type or second type or third type? I said that third type we can identify easily. I'll tell you while doing that. These two are a bit confused. So for that, whenever the question consists of a term called R or end or percentages, okay, you can classify that these comes under second section. So if you what is the probability that they are alternatively of different colors? So as we are not using that what is R or end or percentage, we can say that this comes under the first section only. Means we are not going to use either addition, multiplication or Bayes theorem. Now let us come to the question here. What are the different combinations here? Total balls will be 10 plus 6, which is nothing but 16 balls. So 16 balls are there. Now the question is, what is the probability that they are alternatively of different colors without replacement? Without replacement means you are given with 16 balls. You have out of in the first 4 balls are drawn, means in the first one you have selected one ball. Initially the size is 16. For the second one, it is not replaced, means the size reduces to 15. Next one 14. Next one 13. Got it, girls? 4 balls are drawn and they are not replaced back. Initially the bag contains of 16 balls. One ball is selected. After selecting, the ball is not being replaced. So for the second draw, the total number of balls will be 15. Similarly, the selected ball is not replaced. For the third one you are going to have 13. Similarly for the fourth draw you are going to have 13 balls. So these are the total number of balls for each draw. This is for the first draw, second draw, third draw and fourth draw. Now they are alternatively of different colors. Means let us write P of W as probability of selecting white ball. Okay, probability of selecting white ball. Probability of V as probability of selecting black ball. So first you have the first draw. First draw, what are the total number of events you have? 16. For the second draw, as you are not replacing, 15. For the third draw it is 14. Fourth draw it is 15. Now alternatively of the different colors means probable. First if you start with alternatively means if you select first as white, second should be black. The combination should be white, black, white, black. If they are alternative, all the four selected balls should be. So you should find out probability of white. Probability of white means, right, what is the definition for probability? Favorable number of cases by total number of events. What are the total events here? 16. How many white are there? I have 10 white. Okay. In the second draw, alternatively means probability of black. How many black are there? 6. What are the total? 15. Probability of white. Already we have selected one white from 10. So the total is 14 here, 9. Probability of black means originally we have 6. But one is selected. It reduces to 5 by 13. The total probability will be 10 by 16 plus 6 by 15 into 9 by 14 and into 5 by 13. Similarly, you can try with the second one also. Similarly, alternatively black means you will get with 6 by 15, 10 by 15, 5 by 15, 9 by 15. Okay. So similarly, let us go to the go to the second combination which is already in your book. So let us do the another problem of this without using the theorems. So the data is given to you where you have monthly wages and number of workers. So 1200 to 1400 who receive the rupees monthly wages, there are 9 employees, and 40 those people who receive the salary between 16 to 14 and there are 108 workers, and those who receive from 1600 to 1800 there are 488 and so on. The data describes that. The first column indicates the salaries and the number of workers. Okay. The first column indicates the salary range and the second block indicates the number of employees who how many employees receive in that range. Now the question is nothing but when an individual is selected, you will refer to this number, an individual is selected at random, find the probability that his wages are under. The first bit is what is the probability that the selected person have a salary of less than 1600 and 2000 and above. Okay, and between 1800, 2000 or 1400, 1600. Okay, now greater than 1600 means it comes from the range less than 1600 means what are the possible ranges? Maybe between 1200 to 1400 is one range, 1400 to 1600 is another range. So how many individual earners are there who receive in this 12 to 1400? There are 9 and here 108. So if I want to find out the people who receive a salary less than or equal to 1, the definition is favorable number of cases by total number of cases. What are the total workers you have? 9 plus 108 plus 488 plus 230 plus 119 plus 46. So we no change in the total, but coming to the so the total here is that this is 1000 around, and how many are in this range less than 600? So how many families are there? How many families are there less than 1600? 9 plus 108, which is nothing but 117 by 1000. Similarly, what is the second bit? How many? What is the probability that the selected one will have a salary of more than 2000? Again, favorable by total number of cases. What are the total families again? 1000. So how many more than 2000 means it may be in the range 2000 to 2000 to 2200. It may be in the range 2000 to 2200 and 2200 to 2400. So which is nothing but 119 plus 46 by 1000, which is nothing but 165 by 1000. So this is the way you will calculate without using the theorem, simply favorable number of cases by total number of cases, and you need to find out how many are in the given favorable cases and how many are total. We are not using either addition theorem or multiplication theorem here. Okay, thank you.